This video is a continuation of some of the Chapter 7 stuff, and you can see the screen in the back. This was what I made up to show where the 80% confidence level comes from. Now what we're out to do is we want to find out what these critical values are here. And I'm going to refer to page 5 of the outline notes, and I've got that up here. And you can pause this if you want to get to page 5. But here I'm making up a table of some confidence levels with the critical value. This critical value, it's a z-score. This will be used quite a bit. What we actually do here is we get alpha, which is really the error, or really the part that's not part of the confidence level. The alpha is the stuff that's not in the 80% or 90 or 95%. So what's not in the 80%? There's going to be some over here to the left, some over here to the right. And it's going to be 20% because remember, this whole area, this whole probability adds up to 1. So what we're going to end up doing is we're going to calculate the alpha, the error, and it's 1 minus 0.8 gives us 0.2. But we're really looking for half of that area, and we're doing that because half of the area ends up here and half of it ends up there. And the distance from the mean to this critical point is the same to the right as it is to the left. So what we're going to do is we're going to use invNorm, and I'll show you on the calculator also. But what we want to do is we want to get the area, we're going to look for this z value. So we want, with invNorm, we got to look at all of this area here. It's going to be the 80% plus the 10%, or it's going to be everything under the curve minus what's going on up here. So I'm going to go to the calculator, I'm going to go to invNorm, and what I do is I do 1 minus the alpha, minus 0.1, and I'm looking for a z value, so I've got the standard normal curve where the mean is 0, the standard deviation is 1. I go ahead and put those into invNorm, and I end up getting a number of 1.2816. In the table I put it as 1.282. You'll find in the textbook that sometimes they round these to 2 numbers and sometimes they round them to 3, and it's not really clear. I do want to show you one thing really quick as to what happens if you don't do this 1 minus thing. Let's say we just use the alpha over 2, and so we go here, we go to invNorm, and we just put in 0.1. We just use the alpha over 2, include the mean, the standard deviation, hit paste, hit enter, and we get the same number with a negative sign. If you end up doing this and get a negative sign, you just want to use the number without a negative sign. And just really quickly to look here, on the standard normal curve, right in the middle here, the z value is 0. Everything to the right is positive. So if we look up to this point here, it's going to be 1.82. Everything to the left is negative. It's going to give us a negative number, but we really just want to know that distance there. So that's how we use the invNorm in order to calculate the critical value, the z alpha over 2.